أفلام كورونيت التعليمية. كسوف الشمس وخسوف القمر. الشمس جزء ثابت لا يتغير من عالمنا. كل يوم بسبب دوران الأرض على محورها تشرق الشمس وتضيء الأرض وتبدو سارية في السماء، ثم تغيب فيخيم الليل. للقمر المنير أيضا مكان في اختباراتنا اليومية. الشمس تنيره، وهو كالشمس يطلع ويغيب بسبب دوران الأرض. خلال الشهر يمر القمر في سلسلة تغيراته البطيئة المسماة أوجه القمر. تدريجيا يتناقص نور الشمس الواقع على الجانب المقابل لنا من القمر إلى أن ينعدم كليا، ويكون الليل على ذلك الجانب من القمر، ثم يعود النور إلى الظهور على وجه القمر، ويطلع النهار على ذلك الجانب. لكن يوم القمر يستغرق 28 من أيامنا. أوجه القمر وطلوعه وغروبه كل يوم، وشروق الشمس ومغيبها يوميا، كلها نواح عادية من عالمنا اليومي، أحداث تستمر دون تغيير كبير. لكن أحيانا يحدث ما ليس عاديا. نور الشمس أو القمر قد ينحجب فجأة عن عيوننا، فيكون عندئذ كسوف أو خسوف. الكسوف والخسوف يتناولان دائما الشمس والقمر كليهما، وهما ظاهرتا ظل ونور. الشمس هي المصدر الرئيسي للنور، ترسل نورها لا إلى الأرض والقمر فحسب، بل إلى الكواكب وسائر أجرام النظام الشمسي. لكن كل جسم تنيره الشمس يحجب جزءا من نورها. هذا سبب وجود الظل. رائد الفضاء يحجب جزءا من نور الشمس فيلقي ظلا على سطح القمر، والقمر يحجب جزءا من نور الشمس فيلقي ظلا في الفضاء، والأرض أيضا تحجب الشمس فتلقي ظلا في الفضاء. وفيما تدور الأرض تدخل أقسامها في ظلها وتخرج منه. من وجهة نظرنا الظل هو المتحرك، وهو ما ندعوه ليلا. القمر يدور حول الأرض، وكلاهما يدور حول الشمس فيلقي ظلا. الأرض وظلها يسببان خسوف القمر. القسم الأكثر ظلاما يدعى الظل، وحوله شبه الظل. ظل الأرض المظلم يمتد أكثر من 1,000,000 كيلومتر. الكسوف الشمسي يسببه القمر وظله، وظل القمر يمتد مسافة تقارب بعده عن الأرض نحو 375,000 كيلومتر. قطر الشمس أكبر من قطر القمر نحو 400 مرة، لكنها أبعد منه عن الأرض نحو 400 مرة، لذا يظهران من الأرض بحجم واحد. حين تدخل الأرض في ظل القمر يبدو القمر كأنه يكاد يغطي الشمس تماما. في هذا فوائد عديدة لعلماء الفلك. مرور ظل القمر على الأرض هو ما ندعوه بالكسوف الشمسي. بقاع الأرض التي يبدو فيها القمر مغطيا الشمس تماما تشهد كسوفا كليا للشمس. بقاع الأرض التي تبدو فيها الشمس محجوبة في قسم منها تشهد كسوفا جزئيا. ويتكرر نمط الكسوف كل 18 سنة في دورة تدعى الساهور أو الساروس، اكتشفها منذ آلاف السنين قدام الفلكيين الكلدانيين في الشرق الأوسط. القمر لا ينخسف إلا حين يكون بدرا. طوال ساعات عدة يسير ظل الأرض بطيئا على وجه القمر خلال مرور القمر فيه. خسوف القمر لا يوفر لنا معلومات كثيرة عن القمر، لكن كسوف الشمس يعلمنا الكثير عن أحوال الشمس. في المراصد الشمسية ينكب العديد من الفلكيين على دراسة الشمس. الشمس نجم ناشط ينبض بالطاقة النووية، مصدرنا الأكبر للحرارة والنور. علماء الشمس يستعملون مرايا ضخمة تعكس صورة الشمس في مختبراتهم لدرسها، فيكتشفون الكثير عن الشمس وتركيبها وسلوكها وتأثيرها على الأرض. يراقبون غازاتها الفوارة الجياشة، وحين ينحل نور الشمس إلى ألوانه الموشورية يتعلم العلماء أمورا كثيرة عن تركيب غازات الشمس وتصرفاتها. إذا لم تكن الشمس قريبة من الأفق تصعب جدا مراقبة بعض خصائصها ونشاطاتها بسبب اشتداد توهجها. هناك جزء من جو الشمس لا يرى بصورة طبيعية إلا حين يمر ظل القمر على الأرض. جسم الشمس أشد توهجا من جوها، فلا نستطيع رؤية الجو إلا خلال الكسوف، وسترون فعلا خلال الدقيقتين التاليتين كسوفا كليا للشمس. وهذا يقتضي مرشحات خاصة لتصويره بسبب الوهج الشديد، ومن الخطر مراقبة الكسوف دون وقاية العينين، فلا يجوز النظر إليه مباشرة إذ قد يصيب العينين عطب دائم. لنلاحظ الآن. حين يحجب القمر كل الشمس في الكسوف الكلي نرى إكليل الشمس. الإكليل هالة من نور تمتد ملايين الكيلومترات من الشمس في الفضاء. دراسات الإكليل توفر لنا معلومات عن مغناطيسية الشمس والقوى الكهربائية التي تولدها، والريح الشمسية المكونة من جسيمات مكهربة تصل إلى أبعد حدود النظام الشمسي. بانحجاب نور الشمس الوهاج خلال الكسوف نرى سيول الغازات الحارة المتدفقة من الشمس، الشواظ واللهب، قارنوا حجمها بحجم الأرض. لما كانت هذه المعلومات عن الشمس ونشاطها لا تتوفر إلا خلال الكسوف، فقد ابتكرت أجهزة تحجب نور الشمس كما يفعل القمر. هذه الأجهزة المسماة بأدوات المراقبة الإكليلية توفر للفلكيين وسيلة مهمة لدراسة الشمس. ولكن مهما علمتنا هذه الكسوفات المصطنعة بأدوات المراقبة الإكليلية فلا شيء يضاهي جلال كسوف الشمس وخسوف القمر الطبيعيين الحاصلين من تفاعل الشمس والقمر والأرض في حركتها الدائمة وسط الفضاء. ترجم هذا الفيلم وتمت دبلجته إلى العربية في مؤسسة الأعمال التلفزيونية بيروت، لبنان. أفلام كورونيت التعليمية.
All right. Yeah, in case you literally have been under a rock, today there is a solar eclipse in the United States. And so I'm showing films, 16mm films, about eclipses and the sun and the moon. And so, yeah, and we'll be done by the time. So supposedly in Raleigh, it's going to be 3:15 Eastern Daylight Time. So, yeah, some of you might be getting it earlier. But what do we got? Here's a film about eclipses. I'm Skip Alzheimer. Welcome to the AV Geeks Lunchtime Streaming Show. Did I say that? Yeah, that's me and what we're doing. Eclipses. Enjoy.
The mysteries of nature are as infinite as they are fascinating. Thousands of books have been written in an effort to explain these mysteries. And the man who can best explain them is, of course, our friend with the encyclopedic mind, Mr. John Kieran. Right now, Mr. Kieran is in his library with Paul Milford, his next-door neighbor. Let's listen.
John, we've been looking down at the ground and under the water pretty consistently through that magic kaleidoscope of yours. How about looking somewhere else?
Fair enough. How'd you like to see an eclipse?
Well, I think I would. I don't recall having seen any lately.
Well, not surprising. You don't see eclipses every day. They are certainly one of the most magnificent spectacles that the human eye can behold. By the way, you know why we have eclipses?
Oh, sure. It's, you
don't have to say another word. You know, savages used to think that an eclipse was caused by dragons trying to swallow the sun or the moon. But we know better now, and we can show how it occurs. You are looking at a moving picture of a total eclipse of the sun. It's a long time between total eclipses of the sun in any given area, and they pass very quickly when they do occur. There are also eclipses of the moon. They last a little longer, but they are even rarer sights on Earth than eclipses of the sun. Now, we propose to show, not in a deep scientific fashion, but in a simple way, how these eclipses occur. That spiked knob in the center there can represent the sun for us, and the spinning ball going around it, the Earth. We know the Earth does go around the sun once a year. Now we also have a smaller ball going around the Earth that can represent the moon. We know the moon does go around the Earth about once in 4 weeks or so. These models are not in scale for size or distance, but just for our convenience. This is the silvery light of the moon over which we wax so sentimental, but to tell you the truth, it's borrowed light. It shines by reflected glory from the sun. Now we know that we have a full moon, a half moon, a new moon, and all that. A full moon is when it is in this position on the far side of the Earth from the sun, and we have a full reflection from the rounded surface of the moon's body. Now, the Earth, being a solid body, casts a shadow. And when the moon goes behind the Earth in this fashion, you would think that it would fall into the shadow of the Earth. Well, it occasionally does, just like that. Then the moon is what we call eclipsed. Now, here's another illustration of it. Here, the light of the sun is coming from the left, where the arrows point. The dotted line is the path of the moon. The Earth is in the center, throwing that heavy, dark shadow through which the moon is now moving. The shadow of the Earth there, where the moon is going through, is approximately 5,700 miles across, so it does take the moon a little time to go through it. Now, this is a moving picture of an actual eclipse of the moon, a total eclipse, a central eclipse. It seems that the shadow of the Earth is creeping across the face of the moon. Of course, it really doesn't happen that way. It's the moon that sails into the shadow of the Earth and sails out again, too. Notice that the shadow of the Earth is curved. It's a circle, and that's another way of proving, of course, that the Earth is round. Sometimes the moon doesn't go all the way into the shadow of the Earth, only partially. Then we have a partial eclipse of the moon, something like this. Incidentally, a total eclipse of the moon can take about an hour and 40 minutes at a maximum, but we speed things up here for our own convenience by time-lapse photography. Now, this is another graphic illustration of the path of the Earth around the sun being in the center, and the path of the moon around the Earth. We also show the shadow of the Earth into which the moon occasionally goes to be eclipsed. Now, if these things were all on a level, as we might say, then every time the moon went behind the Earth, it would be in that shadow, and we would have an eclipse at every full moon, but we don't. The reason for that can be shown if we put them in this fashion, and you'll see that the orbit of the moon around the Earth is not in the same plane as that of the Earth around the sun. It's tipped at that angle, which is roughly a little more than 5 degrees, 5 degrees, 8 minutes, say. So that most of the time on its trips around the Earth, the moon is either above or below a straight line through the Earth and the sun. It's only when the three bodies are in a straight line that an eclipse can occur, that the Earth can throw a shadow that the moon will enter, or that the moon can be interposed between the Earth and the sun. Now here the moon has gone into the shadow of the Earth and is in eclipse. Now we remember that the moon also goes between the Earth and the sun. And when it gets into a straight line, then the shadow of the moon falls on the Earth in this fashion. There it's creeping up, and now it's well on the surface of the Earth there. Here we have a graphic illustration of it, the sun's rays coming up from the bottom, the cone shadow, because the sun is so much larger that the shadow of the moon is a cone, and it writes a narrow line of that kind on the surface of the Earth. Of course, the astronomers figure out in advance exactly where that narrow band of totality, as they call it, will fall on the face of the Earth, and then they pick a good spot on solid ground, because a lot of that path lies across water, and go to that place to make their observations. Now here's another illustration. We let the light coming from the right be the sun, the ball hanging in the middle be the moon. When the light shines, you see the shadow falls on the screen, which can be the surface of the Earth. The shadow is darkest at the center, then it fades out to a partial shadow, and beyond that there is no shadow or eclipse. Well, it's the same way with this path of the total eclipse that's dark and complete shadow. Beyond that, for a couple of thousand miles, we have a partial eclipse where only part of the light is cut off. And beyond that, there is no eclipse at all. People who live there are able to see the sun clearly, and the moon is not in the way. Now, there was an eclipse of the sun on June 19th, 1936, in Japan. That is, it was visible from Japan. This is merely a repetition to show how on most of its trips around the Earth, the moon is either above or below the point of straight lines and no eclipses occur. And this is an illustration of the sun on the right, the moon in the center, and the path of total and partial eclipse thrown on the surface of the Earth. The eclipse in Japan caused a great many scientists to gather there, of course, with all their instruments to take measurements of the relative positions of the sun, the moon, and the Earth, and make observations on the planet Mercury, which is very close to the sun and best viewed during the time of total eclipse. And they measure the heat, the radiation thrown off by the sun, and they take views of stars that they can only see at that time, because they also are close to the sun. Some of the natives don't take any stock in that. They think it's a dragon swallowing the moon, and they beat on dishpans to scare off the dragon and save the sun. And when the eclipse is over, of course, they take credit for driving away the dragon and saving the sun for us. Of course, the astronomers don't take much stock in that theory. They have, as I say, their own purposes and scientific measurements to take. Watch this approach to the moment of totality. We are now getting to the stage of what's called the diamond ring appearance. Let that glow up at the top represent the diamond, and you'll see why this is called a diamond ring stage of a total eclipse. We can also see other phenomena at such times where the arrow is pointing. That is called a solar prominence. It's a huge explosion of incandescent gases. Now that arrow on the right points to a globe representing the Earth, 8,000 miles in diameter, so you can see the vastness of that explosion, of that solar prominence. where there was a wonderful total eclipse of the sun visible from Minnesota to Connecticut on January 24th, 1925. I saw it. Certainly was a magnificent, awe-inspiring spectacle. It lasted only a couple of minutes. The total possible length of the eclipse of the sun is 7 minutes and a fraction. But the astronomers will settle any time for a 3 or 4 minute total eclipse without interference by the clouds. As I say, it doesn't last very long. The next one visible in the United States will be from Florida to North Carolina, March 7th, 1970. Maybe we can meet there. But it's very quickly over. You'll see that the sunlight is now streaming around the edge of the body of the moon, which is moving away. In fact, it looks as though day is breaking. The rooster salutes it with a crow. And really, although it's a magnificent spectacle to all of us, it is a relief to have the sunlight by which we all live and breathe come streaming back to us on Earth again.
The oith. I really, really love that guy's narration. And he did a whole series of different films. I have ones on animal intelligence that he did, but this was something that was, I believe, was syndicated for television, so it would be shown. The oith. And yes, I like that some of you in the comments said that this is, James Brill would not tolerate this. Like James Brill and his tight enunciation, and everything is exact and perfect. John Kiernan, that's a good enough take. I'm gonna go grab a cigar. Just really awesome. Yeah, the next one is from Florida to North Carolina, 1970. Maybe we'll all meet each other there. Really great. Okay, this is a NASA film. Enjoy.
Welcome to the observatory. But this is not an ordinary telescope in which we see the reflected images of the heavens. Our imaginary instrument can scan all space and even move in time to suit our convenience. With it, we can watch the birth of the sun, normally a matter of several 100 million years. In our observable universe, there are 1 trillion billion suns, you know. More than 100 billion in our galaxy alone, in all stages of development. So the image you see is a great deal more than guesswork. We focus on empty space, a big ball of it, 10,000 billion miles wide, but not so empty at that. The so-called void is cluttered with a sparse sprinkling of particles, single atoms and ions, small grains of space dust. In the course of time, and by the force of attraction of mass, call it gravity, an infinite number of these infinitesimal particles are drawn together into a tiny ball, 1 million or so miles across, packed so tightly that at the center, nuclear fires start to rage at 20 million degrees Fahrenheit. This is the size and temperature of our sun, incidentally. And what of planet Earth? In our solar system, not all the flotsam of space ended up in the sun. 9 planets were formed on its fringes. Ours is third in order, reading from in to out. 10 years ago, we believed that beyond 70 or so miles of our atmosphere, there stretched some 93 million miles of frozen nothingness between us and our sun. Since then, NASA has boosted probes beyond the blanket of our ionosphere, explorer spacecraft, orbiting solar observatories and the like, and they have begun to map the void. They have discovered the environment around us is far from empty. Surrounding us are vast fields of trapped particles of radiation, the Van Allen belts, running in a continuous girdle 600 to 40,000 miles out from Earth. Particles trapped in our magnetic field in what is called our magnetosphere. Science assesses the discovery of the Van Allen belts as one of the 10 most important events in all recorded history. Where do they come from? For the answer, let's move in on the sun. For comparison in size, our viewing instrument has placed Earth alongside that puny green and yellow pygmy. Great solar eruptions lash out into space from the sun, hundreds of thousands of miles high, 100 times the width of the Earth. And flowing from the sun is a constant stream of charged particles. NASA has put spacecraft into orbit around the sun. These satellites monitor the radiation and the spray of ions the sun hurls outward, creating a solar wind that blasts through space toward our planet like flying spray from some cosmic lawn sprinkler. The magnetosphere acts as our shield against these tiny particles, deflecting the solar wind. A monster bow shock is built up in space, starting 10 Earth radii towards the sun. And streaming out behind is a plume, like the wake of a boat, elongating our magnetosphere. Earth and sun are in constant interaction. As we map space, probe deeper, and learn more, we hope to find the source of Earth's changing weather, the changing conditions that govern our communications, to learn more of our beginnings, and perhaps of our future. Ours is a sun in the prime of life, not yet 5 billion years old. But there are old suns whose hydrogen fires have started to burn low. First, they swell and redden, expanding to 200 times their original size. Then comes a collapse under the weight of helium ashes. The pressure of the collapse raises the temperature 10 times hotter than before. The helium burns in nuclear holocaust. Alternately flaring and shrinking, a dying sun manufactures different atoms down the atomic scale until in final collapse, it reaches temperatures of 100 billion degrees in a vast explosion. The elements manufactured in the nuclear furnace of its interior during its lifetime are dispersed into space. Space dust, joined by other space dust, and perhaps later in the history of the galaxy, another sun will be born from clouds of hydrogen enriched by the products of this explosion. This was the beginning of our sun, those several billions of years ago. And today, almost 100 million miles away, nourished by its life-giving light, shielded from its lethal solar wind, we live and learn.
Here I am. Yeah, that kind of 70s hippie pagan sun talking to you at the beginning. That's pretty great. That'd be a good tattoo if somebody wants to get one. Just saying. So we are watching old 16mm films about the eclipse, the sun, the moon, etc. Here is the sun and how it affects us. Enjoy.
The sun is our nearest star and the center of our solar system. It is a medium-sized star, about 93 million miles from Earth. The sun, directly and indirectly, has been the major source of energy on Earth. That small portion of its light and heat that is radiated to Earth makes life as we know it possible. The sun's heat also helps evaporate the water that becomes clouds and eventually returns to Earth as rain. The sun's heat helps cause winds by heating the air. The sun also indirectly provides us with nearly all our major fuels. A tree, like all green plants, manufactures food by a process called photosynthesis, which depends in part on the energy of sunlight. The food is manufactured in the leaves of the tree and then used in its growth. The sun's energy is stored in the wood of the tree as it grows. And this energy is released when the wood is burned. When coal burns, the sun's energy is also being released. It was stored in prehistoric growing plants that eventually were changed into coal. Petroleum is believed to have been formed deep underground from the bodies of tiny prehistoric plants and animals. If that is true, when petroleum or products of petroleum are burned, energy from sunshine is released that was stored in the plants and animals when they were alive. Most of our machines today depend on fuels containing the stored energy of the sun. It is easy to see how great an effect the sun has on our daily lives. We think of our Earth as a big place. The Earth is almost 8,000 miles in diameter. But the Earth is tiny compared to the sun. If the Earth could be seen against the full sun, it would seem to be just a dot, for the sun is immensely bigger. The sun is approximately 864,000 miles in diameter. It is a great ball of glowing gases, far hotter than anything on Earth with which we are familiar. On a very hot day on Earth, the temperature may be over 100 degrees Fahrenheit. The sun is far hotter, hotter than the 2012 degrees at which glass melts. Hotter even than the nearly 3,000 degrees at which iron melts. The temperature on the surface of the sun is at least 10,000 degrees. And deep inside, perhaps 40 million degrees. We know our solid Earth has a surface and an atmosphere. The part of the sun that seems to be its surface is called the photosphere, which means ball of light. But this is only the apparent surface of the sun, for the gaseous sun has no definite surface as the Earth does. During a real or artificial eclipse of the sun, its atmosphere can be seen. The corona is the most outstanding part of the sun's atmosphere. It appears as a great halo of light, extending at times nearly 10 million miles into space. Scientists believe that our Earth and its atmosphere are composed of the same elements that make up the sun and its atmosphere. The sun's energy comes from nuclear reactions, probably similar to those that occur in the release of energy in the hydrogen bomb. In the process, matter is converted into energy. This process has been taking place in the sun for billions of years. A different kind of activity takes place on the surface of the sun. This is a photograph of immense clouds of luminous gas that are shooting up from the surface of the sun to a height of 80,000 miles. Such clouds are called prominences. Compare the prominences with the size of the Earth. These motion pictures of solar prominences have been speeded up several hundred times to make the action clear. Most prominences are not as spectacular as these, which are rising nearly 100,000 miles above the surface of the sun. Another kind of solar activity is called a solar flare. Bright flashing solar flares sometimes throw out great amounts of gaseous particles from the sun, some of which enter the Earth's atmosphere. The spots on the sun in this photograph are called sunspots. The larger of these sunspots are big enough to enclose the Earth. Scientists are not really sure of their nature. Even these telescopic motion pictures of sunspots don't clearly show what sunspots are. It is believed that sunspots may be magnetic storms on the sun, that we are really looking down on great whirlwinds of matter. Sunspots only appear dark because they have a lower temperature than the brighter parts of the sun. Sunspots may last from a few hours to many days. The number of sunspots seems to increase and decrease in an 11-year cycle. Astronomers learn through the movement of sunspots that the sun rotates on its axis once in about 25 days. Explosive solar flares often accompany sunspots.
Saludos, amigos.
Shortwave radio broadcasting is often affected on Earth when there are large solar flares on the sun. Broadcasts from overseas often fade out for many minutes. These flares on the sun disturb many forms of electrical communication by creating magnetic storms on Earth. Matter ejected from the sun is also believed to cause the brilliant aurora, the northern and southern lights. No one is sure yet of the full effect of sunspots on our lives, but there seems to be a relationship between sunspots and the growth of trees. Scientists have found that trees show greater growth about every 11 years, which seems to correspond to the sunspot cycle of 11 years. Just how sunspots on the sun alter conditions on Earth that control the growth of trees is not definitely known. It may be that our weather is affected in some way by sunspots. Scientists may be better able to predict weather on Earth as they gain a better understanding of activities on the sun. While much of what happens on the sun is not visible to our eyes, one spectacular event can be seen: a solar eclipse, caused when the moon comes directly between the sun and a part of the Earth. The action of this eclipse, seen through clouds, has been considerably speeded up to make the motion clear. Here we see the total eclipse and the corona. Ancient people feared eclipses, for they did not understand their nature. Today we understand many things about the sun. The sun is a star, the center of our solar system, and the major source of energy on the Earth. It is a gigantic nuclear furnace that has been pouring matter and radiation into space for billions of years, and will probably continue doing so for billions of years to come.
yeah, we got a bunch. We got a bunch. Let's see. This next film is a cornet film, but it ultimately was animated by a Japanese film company, Gakken, and they did a couple of really fascinating animated films that look like they're paper cutouts, kind of a more elegant, mildly Asian version of South Park, what South Park is trying to be, but just very pretty. So this is about the moon and a moonbeam and a princess. Enjoy.
One night, long ago, the moon shone over Japan, and a sparkling moonbeam flew down to a grove of bamboo. Next morning, a kind-hearted woodcutter made his way to the forest. It was his job to cut and sell bamboo. What was that light, he wondered? There, in the bamboo, a baby, a tiny baby girl. The man carried the child out of the woods. He brought her home to his wife, and they decided to care for her as their own daughter. They wondered how she may have come to be in the bamboo, but they had no idea. To care for the child, the woodcutter knew he would have to work hard. Bright and early, he began to cut bamboo, when all of a sudden, in the bamboo, gold appeared. With the gold, he was rich enough to build a finer house and to care for his new daughter as if she were a princess. And so the years passed. The woodcutter and his wife became wealthier, and the little girl grew. "23 years passed, and the little girl became a beautiful young lady. So beautiful, in fact, that young men came from near and far to have just a glimpse of her. Three of the young men were princes, and each vowed that he would marry the beautiful lady. When they came to call on the woodcutter, he asked, "Who are you, gentlemen, and why have you come?" The young men explained, "I am Prince Ishizakuri." I am Prince Otomo. And I am Prince Miyushi. Each of us wishes to marry the beautiful lady. The old man, not knowing what to do, went to ask his daughter. Father and daughter spoke for a long time. My daughter will marry the man who brings to her one of 3 rare and precious gifts: the bull used by the great Lord Buddha, the 5-colored jewel of the dragon of Horai Mountain, and a jeweled twig from the tree atop Mount Kurumamochi. Prince Ishizukuri set out first, thinking only of the lady and the gift he would bring her, the bowl of the great Lord Buddha. He traveled for nearly 2 years, but he found nothing. And then, one day, he was lost in a sandstorm. When the prince awakened, he found himself before a strange cave. Deep within the cave was a temple, and on the walls, the statues of gods and demons. At the head of them all, a great statue of the Lord Buddha, guarding the bowl. Was the statue alive? Would it let the prince escape with the bowl? The stairs were magically removed by the demons. He fell. And that was the end of Prince Ishizukuri. Prince Otomo traveled by sea, thinking of the lady and of the jewel he would have to take from the dragon of Horai Mountain. What was happening? A storm was approaching, a storm such as Otomo had never seen. And then, up in the sky, Otomo saw the dragon. Otomo ordered his men, "Fight for your lives." The dragon struck with lightning and great waves. Could Otomo win? His men were lost. All the men. He was the last to be destroyed. And that was how Prince Otomo met his end. Prince Miyushi was a very different kind of man. To win the lady, he would have to bring a jeweled twig from Mount Kurumamochi. But Mount Kurumamochi was far away, and the trip was dangerous. He had a scheme in mind. Instead of going to the mountain, he waited till nightfall when no one was watching and went to the shop of a silversmith. The prince asked the smith, "Can you make such a jeweled twig?" And the smith agreed to try. The twig was beautiful, a masterpiece. But when the smith asked for the money he'd been promised, the prince seized the twig and struck him down. Miyushi brought the stolen twig to the lady, along with a made-up story about how he had gotten it. He said he had traveled hundreds of miles and battled fierce demons. He said he had conquered an enchanted tree, that great bats had carried him high in the sky until he had found the jeweled twig. It was a grand story. But Miyushi hadn't expected the silversmith to come and tell the truth, that he had made the twig. Miyushi was caught. When the silversmith tried to take his twig, Miyushi drew his sword. The twig was destroyed, and Miyushi was defeated. Time passed. The seasons changed. And one night, as the moon shone down, the lady was seen to be weeping. When the woodcutter and his wife asked why, she explained that many years ago, before they had found her, she had been a princess on the moon. The moon, with its beautiful cities and its gardens of magic moonflowers. Of course, she had been just a baby princess and very careless about flowers. Once, when the gardeners were planting, she danced through the blossoms. The flower bed was ruined. The gardeners rushed to the palace, and the king sent a soldier. The king was told what the little princess had done. And this was her punishment, to be sent far away to Earth. Far away from her beautiful home on the moon. She had drifted gently, closer and closer to the Earth. And so she had arrived at the bamboo grove, where the woodcutter had found her. But now she was sad. the time had come for her to return to the moon. The woodcutter did not want to lose his daughter or to have her unhappy. He went to the Emperor of Japan and begged his help. And so the next night, when the full moon shone over Japan, the emperor called up his army and sent them to guard the princess. They arrived at the house, set up fortifications, and boarded up windows and doors. The emperor's soldiers stood guard on the rooftops. The woodcutter waited. The princess and the emperor waited. Suddenly, they saw a bright glow coming from the moon. A moon cloud carrying spirit people from the moon. "We have come for our princess," they said. The emperor's men replied with arrows. But their arrows were gently returned, with no harm to the soldiers. "Thank you for taking care of our princess," said the moon people. And they sent a moonbeam down to the house and toward the princess. Slowly, she was carried up the moonbeam. How sad everyone was to see her go. The princess saw that all her friends on earth were unhappy. So she turned back for a moment and threw a shining ball of light. Scattering into brilliant fragments, the light touched the earth and became flowers, hundreds of magical flowers. With this gift of flowers, the people would find happiness again. Now it was time for the princess to leave. "Goodbye," she said. "Goodbye. I'll never forget you." "Goodbye." And so, the Moonbeam Princess returned to her home.
Everybody needs energy-packed Sunbeam Bread. Yes, it's all aboard for fun in the park, but Junior hasn't got energy enough for fun. He'd sure like to ride that horse. Hey, what's this? An energy-packed Sunbeam sandwich. You bet every delicious slice of Sunbeam Bread sure does pack a big energy wallop. There's nothing like Sunbeam Energy to help you stay on the beam. Now, look at them go. On Sunbeam Energy, they sure do enjoy life. Everybody needs the kind of real zip and zing pep that delicious Sunbeam Bread gives you. Yes, stay on the beam with energy-packed Sunbeam Bread. All day long, eat Sunbeam Bread and renew energy as you burn it up. Eat delicious Sunbeam Bread.
This buckaroo is ready for the bunkhouse way before his bedtime. Better wake up, partner, 'cause here comes that fresh energy you need. Yes, now he'll perk up and feel peppy again with energy-building Sunbeam Bread, the favorite bread of Hop-Along Cassidy. And here's some of that Sunbeam energy going to work. Our young cowboy friend has written a letter to his hero, Hop-Along Cassidy. Now then, let's see what it says. Dear Hoppy, I eat your favorite bread, Sunbeam Bread. You sure are right about the energy it gives. Sunbeam Bread tastes like a million, too. Thanks, Hoppy, for telling me about your favorite bread, Sunbeam. Yes, mothers, reach for Hoppy's favorite bread. Reach for Sunbeam, the bread you need for energy. Hey, young fella, that takes energy. Better make sure you replace it. Lasso a bundle of energy, a loaf of swell-tasting Sunbeam Bread. Every slice of Sunbeam Bread helps to restore your pep and zip. How about it, boys and girls? Lasso yourself some of Hop-Along Cassidy's favorite bread. You'll go for the swell taste of Hoppy's favorite, fresh, nourishing Sunbeam Bread. Sunbeam Bread is packed with energy values you need to keep you raring to go. It's swell for snacks, tops for toast, and great with every meal. So get the nourishing loaf with Hoppy's picture on the wrapper end. Reach for Sunbeam Bread. Ask Mom to buy fresh, tempting Sunbeam, the bread you need for energy. Hurry, Billy. Don't miss the Sunbeam Roundup. Hit that saddle and head for the grocery store for a loaf of Sunbeam Bread. It's the favorite bread of Billy's favorite cowboy star, Hop-Along Cassidy. And there's another good reason why Billy goes for Sunbeam, why you'll go for Sunbeam, too. Sure, he wants to be like Hoppy, even wears his hat like him, but Billy's found out for himself that Sunbeam Bread is the freshest, tastiest bread ever to tickle his appetite. Yes, it's easy to see why Hop-Along picked Sunbeam Bread as his bread. Sunbeam Bread is so good, so nourishing, so fresh and tender, too. So make Sunbeam Bread your favorite choice. Eat Sunbeam, the bread you need for energy. Hey, young fella, that takes energy. Better make sure you replace it. Lasso a bundle of energy, a loaf of swell-tasting Sunbeam Bread. Every slice of Sunbeam Bread helps to restore your pep and zip. How about it, boys and girls? Lasso yourself some of Gene Autry's favorite bread. You'll go for the swell taste of Gene Autry's brand. Fresh, nourishing Sunbeam Bread. Sunbeam Bread is packed with energy values you need to keep you raring to go. So get the nourishing loaf with Gene Autry's picture on the wrapper end. It's tops for toast, swell for sandwiches, and great with every meal. So reach for Sunbeam Bread. Fresh, tempting Sunbeam, the bread you need for energy.
Be sure to buy Sunbeam Bread for fresh, delicious sandwiches. Sandwiches that are wonderfully rich in vitamin value. That's energy-packed Sunbeam Bread. Give your family the foundation of a complete diet with enriched Sunbeam. Help them keep on the go with Sunbeam Bread. Schmidt's Blue Ribbon Bread gives you 7 ounces of non-fat milk solids in every loaf, the equal of 90 quarts a year if you serve it regularly. Every sandwich you make, every snack, gives you extra milk. For wonderful flavor combined with sound food values, serve Schmidt's Blue Ribbon Bread in the pantry pack.
He's out to rustle up something mighty important. What? No more Sunbeam left? This calls for immediate action. let's go for some energy-packed Sunbeam Bread. Oh, yes, better stock up. There's no time like the present. Straight ahead for Sunbeam. Sunbeam Bread is the popular attraction. The nice, fresh flavor of Sunbeam, plus the sound energy value, makes it a winner with all the folks. And what's so important, Sunbeam Bread gives the folks energy from a good, pure food source. Yes, it's delicious Sunbeam Bread for a real zing of energy. So, you get nutrition plus energy in every slice. Eat grand-tasting, wonderful, energy-packed Sunbeam Bread 5 times a day for energy-packed meals and delicious snacks, too. Buy only energy-packed Sunbeam Bread. Summertime, picnic time, outdoor time, and time to enjoy yourself. Get in the swim, have sun fun, and that calls for lots of reserve energy, the kind of sparkling energy you get from good energy-building Sunbeam Bread. The basic ingredient here, delicious Sunbeam Bread sandwiches, the bread you need to give you the pep you need, and along with everything else, it tastes delicious. Now, he looks happy with lots of vim, vigor, and vitality, and she also is full of the kind of pep you admire. She got that energy from Sunbeam Bread. See what we mean? Say, fella, you better watch out. You can never tell what will happen. Uh-oh. Well, he'll feel better with another Sunbeam sandwich. Is that good and full of energy? So, take a tip. Make super delicious, super fresh sandwiches with Sunbeam.
So I showed Moonbeam Princess, so I had to follow up with some sort of Sunbeam thing, and that was, of course, wheat that had been ground so that there was no nutritional value whatsoever. Sunbeam Bread. It's fascinating to see how much cachet having cowboys, fictional cowboys, associated with bread products were for young boys. At least that's what Madison Avenue thought. But yeah. Okay, well, thanks for tuning in today. For those of you who are observing it, there is an eclipse coming. If it's not already showing up in your neck of the woods, don't look at it directly. Get a colander. We did last time it happened here in Raleigh. We had a colander, and it made hundreds of little tiny pinhole eclipses. It was really actually awesome. And then walking back, we realized that all the leaves, as sunlight was filtering through it, there were also hundreds of little projections of the sun being eclipsed, and that wasn't even a full eclipse. So it was really, really awesome. It felt weird. It's worth taking a break and watch it. So I'm going to be traveling the rest of this week. I'm going to be in New York City for the Orphans Film Symposium, which starts Thursday morning. And so I'll be pre-recording shows and maybe trying to show locations and people. Yeah, it'll be fun. Try to go to some archives, try to see some archivists, etc. But everybody have a great rest of your day. If you like what you saw, hit the thumbs up, hit the like button. You can go to ko-fi.com/abgeeks, patreon.com/abgeeks, or donate via the super thanks button, which Jeremy did. So thank you so much for that. Yeah, we will see you. I'll be flying as the show is happening, so I won't be able to check in, I don't think. But yeah, we will see you on the other side. Take care, everybody. Love you guys. See you soon. Bye.